All right, it's a little bit goofy because I forgot to put the introduction in here. So today we are covering section 7.3. We're going to start out here with a little bit of a video about explanation of what a unit circle is, and then I'll be back and we will talk about and look at finding exact trig values within that unit circle.
And radians relate, finding radian measure, and finding the xy exact coordinates of important radian measures, all under 8 minutes. First, let's talk about what a unit circle is. What you're seeing is an xy coordinate grid. This is a plane with pairs of coordinates, and a unit circle is centered at the origin. There it is, little unit circle with a radius of 1. Let's zoom in to get a little bit of a closer look at it here. Okay, there we go. Now, radius of 1 means that I can lift out this little blue piece here, and this is the radius. And as you can see, no matter where I hold it, it's got a radius of 1 exactly. Now, if we take that radius and we curve it, here's a curved piece. It's the same thing, it's curved and I've colored it purple. If we take this curved piece and we get a few more, 1, 2, 3 more of them, these will fit exactly in the circumference of the circle. But in just a second you'll see, hang on, that there is just a tiny little piece left over. So the radius will fit around the top hemisphere of the circle 3 times plus a little bit extra. And this little bit extra, which is right here, is 0.14 long. So it takes 3.14 radiuses, or radians, to fit around the top half of the circle. Okay, so let's move that little 0.14 piece in there. Okay, 3.14, that is pi. So around the very top half of the circle is pi radians, and the bottom half of the circle is another pi radians. So the complete circumference around a unit circle is 2 pi radians. This should be familiar. If we go to the formula for the circumference of a circle, it's circumference equals 2 pi r. Well, since we've got a radius of 1, that makes the math simple, right? There you go. So now you know how the formula got to be that way. Okay, now I'm going to tell you how radians and degrees relate. So what you're seeing here is a slightly different picture of the unit circle, and the red side, which is moving around, is going to be called the terminal side, and the green side is going to be called the initial side. So I put it in your heads that a radian is a length, and I'm going to adjust this so that, there we go, the terminal side is 1 radian away from the initial side. So this is a length along the outer edge of the circle here. But a radian can also be describing the angle formed by the terminal side and the initial side right inside here. Okay, well, let's bring degrees into this. So there we go. We see this is 57 degrees, and that is the same thing as 1 radian. All right, well, it might not seem very natural and they don't quite go together, but let's just move this around here and we'll see where the logical matchups are. Right here, at exactly halfway point on the way to 1 complete pi radian, this is pi over 2 radians, and that's 90 degrees. And over here we've got 1/4 pi, or just pi over 4, this is the same as 45 degrees. And over here we've got 3/4 pi is 135 degrees. And of course here is 1 complete pi, and that's 180 degrees. But there's a few other important ones. There is 30 degrees, which is 1/6 pi. 60 degrees, which is 1/3 pi. 120 degrees, and although the radians didn't make it look nice, this is actually 2/3 pi, or 4/6 pi. And over here, 150 degrees, which is 5/6 pi. Okay, let's move on. Let's talk about how to convert degrees into radians. The formula for converting degrees to radians is degrees divided by 180 times pi. So I'm going to move this randomly here and just kind of put it there. And we see we've got 72.06 degrees. All right, let's bring in a calculator and try to convert that. 72.06 divided by 180 and multiply that by pi. 1.2576, and that is the angle in radians. Okay, so let's convert between given radians to get a degree measure. Here's the formula for doing that. You take your radians, divide it by pi, and then multiply by 180. Here is the calculation for that. I encourage you to give this a try on your calculator. Just put in 3/4 times pi divided by pi times 180, and there we go, 135 degrees. Okay, we're on to the last part. This is the complete unit circle, and I'm going to show you how you can find the various points of interest, the XY coordinates of places along the edge of the unit circle. What you're looking at is the upper right quarter of the unit circle. Take a look here at the coordinates for 30 degrees or pi over 6. The x coordinate is square root 3 over 2, and the y coordinate is 1/2. So think of this as being part of a triangle, with the vertical leg on the bottom being square root 3 over 2 long on the x-axis, and being 1/2 high on the y-axis. And naturally the hypotenuse is 1 unit long. Now here's where sine and cosine come into play. If you take the sine of pi over 6, you will get 1/2. And if you take the cosine of pi over 6, you will get square root 3 over 2. Now when you do this in your calculator, you'll get a long decimal. But you can confirm that this is square root 3 over 2 by typing it in and taking a look. A final word on some strategies for helping you to memorize some of these XY coordinates along the outer edge. Look for symmetry. Look and see how similar and different the 30 degree and 60 degree mark are. Notice that all the starting x coordinates for everything on the left side of the y-axis is negative. And keep in mind, the only numbers that you have to memorize are 1/2, square root of 3 over 2, square root of 2 over 2. Alright, well hey, thanks for watching this video. Hit the like button if this was helpful, and share it with your friends and your teacher.
Now that you have a basic understanding of what a unit circle is, let's take a look at how we're going to use it. We're going to use it to actually find what we call exact values or exact trig values on the unit circle. So, we're going to look at finding different pieces of this if we're given the measure of an angle. So in this case, if we're given the measure of theta down there on the drawing I have down here or over here, how could we find really, in a sense, the coordinates of that point by creating this right triangle and doing different things with this? And we're going to work on, kind of manipulating our way around this different thing, really looking at finding a sine and cosine of angles. And we're actually going to do secants and those things as well for not only angles that are in degree measures, but also for angles that are in radian measures as well. So a couple more things about the unit circle. We've got a unit circle sitting right here. Again, a unit circle is always going to have that radius of 1. One of the things we want to be able to do is we want to be able to, what are those points, on the unit circle, and where do they fall in? And eventually, at some point in time, I think probably in pre-calc, you're going to have those memorized, those different types of things. And it's not too bad to memorize them. If you don't have them memorized, you can usually pretty easily find them. But if we keep a couple things in mind, this isn't really too bad. Remember, we can drop this down there and we can create this right triangle. And once we've created this right triangle, now I could really call this an x value, and I could call this really, kind of my y value, so to say. So just a couple things with the unit circle to kind of keep in mind. That if we think about the different trig things within this, if we look at the sine of theta, the sine of theta is going to equal y over 1. It's a nice y. It's going to equal y over 1 or just y. And the cosine of theta is going to equal x over 1 or just x. So kind of keep those things in mind, kind of just as a basic of the unit circle. We're not going to, we're going to break it down here in a little bit of maybe an easier way with this, because I think we're going to look at 30, 60, 90s, 45, 45, 90s, and those different types of things. So we should be able to find the length of those sides, without necessarily having to use the sine ratio or the cosine ratio and then pop it into a calculator and that type of thing, because we're going to, like I said, use 30, 60, 90s and 45, 45, 90s and that type of thing. So a couple of things that we are going to look at is we're going to say, okay, on the unit circle, let's find the exact value of, say, the sine of 60 degrees. Okay, so we want to find the exact value on the unit circle of the sine of 60. So that means you're not going to punch in your calculator and hit enter. It means we're going to do it on the unit circle. So we've got this unit circle going on here. Okay, 60 degrees, we've done this before, so 60 degrees is about right there. So we've created this 60-degree angle, and now I'm going to drop this side down and create my right triangle. So I've got my right triangle created. So because I've scrunched it down, I'm going to kind of blow it up over here. So I know I've got a 60-degree angle sitting right there, and our question says find the sine of 60 degrees. We want the exact value of the sine of 60 degrees. So remember, this is a unit circle. So because this is a unit circle, we know the length of the hypotenuse. The length of the hypotenuse is always going to be 1. Okay, that's given. It's a unit circle. The radius is always going to be 1. So I know that this length is 1. Since I know that that length is 1, then I can go ahead and find the lengths of the other sides. Okay, because we've got a 30, 60, 90-degree angle. So we're given the hypotenuse. You go from the hypotenuse, nice drawing, by the way. Obviously, it's not to scale. You go from the hypotenuse to the short leg, which is opposite the 30-degree, by taking it and dividing it by 2. And then you go from the short leg to the long leg by taking 1/2 times the square root of 3, which is the same thing as the square root of 3 over 2. So we're asked to find the sine of 60 degrees. And from up there we said, the sine of theta from our last slide was equal to y over 1, which is just y. So our y value is kind of that up and down. So the exact sine is the square root of 3 over 2. It's opposite over hypotenuse. That's what sine is. Okay. Could we find the cosine of this? Certainly could. Cosine of theta we said was going to be x over 1 or just x. Our x value is 1/2. 1/2 over 1 is just going to be 1/2. So those are our exact ratios of sine and cosine. And in fact, what this then does is it actually gives us this coordinate. Okay, this is the coordinate on the unit circle, 1/2 the square root of 3 over 2 is what that point is. We know this length, we know that height. That's the exact coordinate then of the sine of 60 degrees. Okay. Let's look at another example. Let's go with the cosine of the exact value of the cosine of 135. Okay, and again, we're using the unit circle to do these. So I'll draw this one a little bit bigger. I'm not going to put the unit circle. Let's kind of give the understanding that we're using the unit circle to find the exact value. So we draw out 135. 135 is over here somewhere. Okay, so next thing I need to find is that reference angle. So we know this is 135 degrees. So we talked about the reference angle the other day. The reference angle in this case is going to be 45 degrees. So that gives me a 45, 45, 90. And all of your triangles today are going to be 45, 45, 90, 30, 60, 90, or yeah, those type of triangles. Hypotenuse is always 1. Okay, now we've got a 45, 45, 90. How do you go from the hypotenuse to a short leg? Well, essentially you divide by the square root of 2. So this is going to be the square root of 2 over 2. And this is going to be the square root of 2 over 2. But now we have to think about it a little bit and say, okay, I've gone in this direction. Okay, so I've gone to the left on the x-axis. If I've gone to the left on the x-axis, that means my x value needs to be negative because I've gone to the left. So we've gone left and up. Up is positive, to the left is negative. So we've got the negative square root of 2 over 2. We're asked to find the cosine. Cosine was cosine of theta, which in this case is 45, but whatever. Okay, they're going to have the same values. It's just the same thing. Okay, so cosine of theta, and we're always going to use that reference angle, and the cosine of 135 is going to be the same thing as the ratio for 45. Cosine was our x value over 2, so it's the negative square root of 2 over 2. And we could find the sine of theta as well. Sine of theta was just going to be the square root of 2 over 2. And again, it's going to be negative in this case because of where it's located in the coordinate plane. It's kind of in that second quadrant. So we're going to the left and up. So that x value in this case is going to be negative. So essentially, we're finding the reference angle. I know we said 135. We got that 135. It's going to give us the same ratio as if we use the reference angle because we're drawing that right triangle and using that piece of it. So the key when you're doing these, draw the angle, find the reference angle, and then use your ratios. Hypotenuse is always going to be 1, and then kind of work yourself around as to what really the next thing is going to be. So let's say that we want to find the tangent, but now we're going to say we're going to find the exact value of the tangent of, let's say, 5 pi over 6. Okay, well, our step 1 was to graph this. Okay, so I'm going to graph this. 5 pi over 6, I don't know where that is in the unit circle. It's in radians. So one of the things you had to do in the last lesson is you needed to change something from radians to degrees. So to change something from radians to degrees, we took the radians and multiplied by 180 over pi. The pi's cancel each other out. 6 goes into 180 30 times. So this gives me a 150 degree angle. So that's really step 1, unless you've memorized where 5 pi over 6 is, which you probably haven't. So we're going to go ahead and draw this 150 degree angle. There's a 150 degree angle. I'm going to draw my right triangle. My reference angle is going to be 30 degrees. The hypotenuse is always 1. So now I have to label my sides. So my hypotenuse is 1. That makes my short side 1/2. So my short side over here is right here this time. And my long leg is going to be the square root of 3 over 2. And that's how these are always going to be. Okay, now 30 degrees is my angle that I have to use. So now I have to find the tangent. Well, tangent is opposite over adjacent. So the tangent of 5 pi over 6 is going to be 1/2 opposite over adjacent, the square root of 3 over 2. We really can't leave that like that. So that's 1/2 divide, multiply by the reciprocal. Reciprocal of 2 over the square root of 3 is 2 over the square root of 3. So that leaves me with the that leaves me with 1. I got ahead of myself there. I was going to give you the answer. That leaves me with 1 over the square root of 3, which you can't have. So we have to multiply by the square root of 3 over the square root of 3, which is the square root of 3 over 3. So that's our exact tangent value for a 5 pi over 6 radian angle. Okay. A little bit to it. What did I mess up? Okay, there's a mistake in there. I missed the negative. Sorry about that. So this should have been negative. This negative, I should have had negative square root of 3 over 2, so that's going to make my solution negative as well. Sorry about that. It's a common error in here. Again, left is negative. Left and down to get your negative ones when we're doing these. Okay. Let's look at another one. Let's go with the cosine measure of 4 pi over 3. Again, we're doing exact values. Can't just punch them in your calculators. Okay, so we're going to change it. 4 pi over 3 multiplied by 180 over pi. Cancel, cancel. 30. 120 degree angle, I think. 60. Nope, I lied. That's 60. That's 240 degree angle. Okay. 4 times 180 divided by 3. Just double check. Looks like my math. It's too early in the morning. 240. So I'm going to draw a nice straight line. And I graph 240. 240 ends up being down here somewhere. You have to find the reference angle. So we've gone 240. We got to get back to 180. So that makes this 60 degrees. Draw my right triangle. My hypotenuse is 1. There's my 30. Opposite the 30 is 1/2, and we're going to the left, so it's going to be negative. Opposite the 60 is the square root of 3 over 2, but we're going down, so it's going to be negative as well. We're asked to find the cosine of it this time. So we talked about cosine before. Even if you don't remember that it's x over y or y, whatever one it is, you know cosine is adjacent over hypotenuse. So adjacent is negative 1/2, the hypotenuse is that. So our solution to this, the exact value for this, or find the sine, cosine, is 4 pi over 3. Okay, let's look at another one. Let's find the cosecant. We're going to find the cosecant this time of, let's go with 315. So we're going to find the exact value of the cosecant of 315. Okay, so we've got the angle measure this time already, so we're just going to go ahead and get the angle measure. It's 315, 270, 315 must be right there. So we've got to get to 360, 360 minus 45. So we've got a 45, 45, 90. Hypotenuse is always 1. Go ahead and label my other sides, 45, 45, 90. So divide by the square root of 2, so the square root of 2 over 2. So this is going to be the square root of 2 over 2, but we're going down, so it's going to be negative. And this one's going to be the square root of 2 over 2 as well. Nice 2 again. That's that penmanship thing. And it's going to be positive, so we're going to the right. Now the cosecant. Cosecant is the opposite of the sine. So sine is opposite over hypotenuse. So this is hypotenuse over opposite. The hypotenuse is 1. The opposite, and we're always going from the reference angle. So we're going from the 45. Always the reference angle. Negative square root of 2 over 2. So we've got 1 times 2 over the square root of 2. So we got to multiply by the square root of 2 over the square root of 2. So that gives me 2 times the square root of 2 over 2, which is just the square root of 2. And it's down, so it was negative. So it's negative square root of 2 for that one. And you're done. Okay, let's look at another one. Let's go with 8 pi over 13. So this time we're going to find the sine, cosine, tangent, secant, cosecant, and cotangent. Let's go with 13 pi over 4. So we're going to change it to degrees first. So 13 pi over 4 times 180 over pi. So 13 times 180 divided by 4 is 585. Okay, so let's see if this one works out. So this is 585 degrees. So there's 360, there's 450, 540, there's 585 right there, so that makes this 45 degrees. So we've got 45, 45, 90. So that's my 1. Square root of 2 over 2, and that's got to be negative. And this has to be the negative square root of 2 over 2 as well. So we've got a 45, 45, 90. Now we're going to do the sine, cosine, tangent. So sine is opposite over hypotenuse. So that's the negative square root of 2 over 2. Cosine is the same thing in this case. Negative square root of 2 over 2. Tangent. Let's erase all of this so I have some room. Tangent. It's going to be the negative square root of 2 over 2 divided by the negative square root of 2 over 2, which is this. So it's just 1. Tangent of that is just going to be 1. Secant flips the cosine. I put them in a little bit different order. So it's secant. So that would be 2 over, so it'd be negative square root of 2 over. So secant, so we're just flipping the cosine. So it'd be the negative square root of negative 2 over the square root of 2, which is 2 over the square root of 2 over 2. So it'd be negative square root of 2. That means that this is going to be the same thing. So negative square root of 2. And the cotangent, because it was negative and negative, that's why it's positive. The cotangent is just going to be 1. So there are your 6 trig ratios, or the 6 exact trig ratios, for a 13 pi over 4. 1. Let's do one more. Find a nice, see if we can find a nice one here. Let's go ahead and let's go 4 pi. Let's do a negative one. So let's find the secant of negative negative 225. Let's find the exact value of the secant of negative 225. So negative 225, somewhere right in there. So we've got negative 225, so this is a 45. Nice 45. Okay. So we've got a 45. Again, we always go to that reference angle. We've got 45, 45, 90. Hypotenuse is always 1 and it's always positive. So the square root of 2 over 2, negative. That's the square root of 2 over 2. Secant is the opposite of the cosine, so it's hypotenuse over adjacent. So that's 1 divided by the negative square root of 2 over 2. So that's 1 times 2 over the square root of 2, which is 2 over the square root of 2, which we've done a lot now. So that's just going to be 2 times the square root of 2 over 2, so just the negative square root of 2. Okay, so these are exact values today. No decimals. Your answers should always be in the form of half, 1, square root. Make sure you keep intact kind of those positives and negatives. So just kind of recap, first and foremost, what your triangles are going to look like. So if you've got a 45, 45, 90, Again, we're always looking at the reference angle. You're going to have 1, the square root of 2 over 2, square root of 2 over 2 are going to be your legs. Now, depending on where it is, it's going to be positive or negative. If you have a 30, 60, 90, your hypotenuse is always going to be 1. The side opposite the 30 degrees is always going to be 1/2. And the side opposite the 60 is always going to be the square root of 3 over 2. Those things are always going to happen within these. Now, if your legs are positive or negative, it depends on what quadrant that they're in. Okay, so you got to kind of keep that in mind as you're going along with your assignment today. Right, so there's the unit circle, and again, cutting that piece up there within this unit circle. And this is actually the last section we're going to cover in this chapter. So you got the unit circle stuff tonight. We'll talk about reviewing tomorrow and a quiz here in a couple days. May end up taking the quiz probably Thursday or maybe Wednesday. We'll see. For tonight, you're going to go on page 380 out of the book. You're going to do questions 5, 6, 9, 11, 20 through 23, 26 through 31, and then I want you to do question number 34 and 37. And that should take care of the exact trig ratios. There you go. Hopefully I can get this uploaded in time. Have a good day.